Now we can compute what is called R squared value. Okay. R squared is also called coefficient of determination, and that is given by SSR divided by SST. So in other words, the total sums of squares in the denominator, SSR in the numerator. So SSR, what proportion of the total sum of squares, is now explained by the regression. So if all the points lie on the straight line, the entire variation is explained by SSR. So SSR will be equal to SST. So this ratio will be 1. But that's a very rare case. So the larger the R squared value, the more closely the line will be to all the different points. So larger R squared is a better R squared. So here we can interpret this R squared value as 70.6% of the variance in or variability in the values of y is explained by the regression of y with x. So what remains is the error. So about 30% of the variability, okay, we are unable to explain. So let's go to the Word document and then look at some more properties of coefficient of determination. Okay. So coefficient of determination, the formula is SSR over SST, and you can also express this as 1 minus SSE over SST. Okay. So it is the measure of how good the fit is. Okay. It is interpreted as the proportion of variability in the dependent variable y that is explained by the regression. Some of the properties, okay, R squared will be 1 means there is no error at all. Okay, all the points line up on the straight line. Now SSE is 0. Now R squared is equal to, now if SSE, okay, when SSE is equal to SST, R squared will be 0. Okay, that means x is of no value in interpreting or in predicting y. So if R squared is 0, which is very rarely the case, that means might as well omit x. No need for considering x. So R squared value is always between 0 and 1. It cannot be negative. It cannot be more than 1. Okay. For simple regression only, if you take a square root of this R squared, what you get is the correlation between x and y, linear correlation coefficient. Okay. So if in general square root of R squared is known as coefficient of multiple correlation represented between y and y hat. So y hat being a function of all the x's, so it is actually a multiple correlation between y and all the x's put together in a general case. In the case of simple regression where there is only one x, then it is just a correlation coefficient between y and x. So for simple regression, since there is only one explanatory variable, the square root of R squared R is the absolute value of R. So now what is correlation coefficient? This has been discussed in the second stat class and even in the first also. So R, coefficient of correlation R, is a value between -1 and 1. Okay. The sign of the correlation coefficient indicates the direction of relationship between x and y. Okay. If it is direct relationship, if x goes up, y also goes up, then you'll have positive value for R. On the other hand, like in the case of price and demand, if price goes up, demand will go down. So there you have a negative correlation. So R will be negative. So the sign, positive or negative, tells us which direction the relationship is. And the absolute value of R tells us how strong the relationship is. Okay, either -1 or +1 means very strong, perfect relationship, perfectly negative relationship or perfectly positive relationship. A number that is closer to 0 means the relationship, the association is weak. It's not very strong. So value closer to the two extremes means very strong relationship. Value closer to the midpoint 0 means it is weak. So let's go back to the Excel file. Now let's look at generating the regression results, everything that we have calculated so far using data analysis. So you go to data analysis, okay, and then select regression from the list. Click OK. Now Y range, okay, let's go back up. Y range, if you include the label, that's a good practice to include the label, so we can check the labels here. And then the X range. Okay. Now let's put the output range right here. Okay. Now there are a lot of other information that we can generate besides the basic one, okay, which are these, and we'll talk about these later on. So right now we want to just generate the basic results for regression. Okay, so now click OK. Now that generates our results. Okay, so here it generates a lot of information. Okay, let's look at some of these. Okay, now R squared, so this is the coefficient determination. Square root of that is the multiple R, that is the correlation between Y and all the X's combined, which of course in this particular case will be the correlation coefficient. Adjusted R squared, we'll talk about that later. The standard error is the square root of mean square error. We'll come to that in just a second. So observations, that's your sample size. Now here are the sums of squares table, which is also called ANOVA table. So that is SSR is regression. Residual is simply another name for error. So Excel calls it residual, which is just fine. So remember that this is error. So this is SSE. The sum of these two is the total. Okay. Now you divide the degrees. So degrees of freedom again is one number of X variables, n minus 1 here and n minus 2. Now divide the degrees of freedom into sum of squares, you get your mean square. Now you divide MSE into MSR, you'll get the F statistics. We'll talk about this later on. And then significance of F is p-value. Again, we'll talk about that later. So this is the MSE value. If you take that, if you take a square root of this value, that's what standard error is. Okay. See, if you take square root of that, well, it'll be exactly the same as that. Now the third table gives us the coefficient. So here is your B sub 0 and the X coefficient B sub 1 is right there. And the rest of the information in this table, we'll look at that later on. So this is the basic output that data analysis gives us when we run regression using data analysis.